Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve the exponential problem 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8. Now, to solve this problem, what I'm going to do is, I first have 4 answer choices. So my first answer choice A, this is going to be 8 to the power of 32. My second answer choice B, this is going to be 32 to the power of 8. My third answer choice C, this is going to be 32 to the power of 32. And my final answer choice D, this is going to be 2 to the power of 26. So if you guys know how to solve this problem, you guys can try to find out which answer choice this is. Alright, so now, to solve this problem, let's first go through all the answer choices, starting with A. How they got A was they kept the base the same, so they did 8 to the power of, then they added all the exponents, so 8 plus 8 plus 8 plus 8. And this is equal to 8 to the power of 8 plus 8 is 16, 16 plus 8 is 24, 24 plus 8 is 32. And this method is actually wrong. You can't add exponents like that. So for the secondary choice B, they got 32 to the power of 8, and how they got this was they kept the exponents the same, and they added the bases. So they did 8 plus 8 plus 8 plus 8 to the power of 32. To the power of 8. Now, 8, this is the same thing as 8 to the power times 4, which is 32. So I got 32 to the power of 8. And this method is actually wrong as well. This is not the right way to add exponents. Now, for 32 to the power of 32, they did both. They added all the exponents and the bases. So they did 8 plus 8 plus 8 plus 8 to the power of 8 plus 8 plus 8 plus 8. And they got 32 to the power of 32. And this method is wrong as well. Finally, for D, which is actually the right answer, they first started with, 8. This is the same thing as 2 to the power of 3, right? So we have 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8 plus 8 to the power of 8. And now if I substitute in 2 to the power of 3, I get 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8 plus 2 to the power of 3 to the power of 8. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, a is equal to 2, m is equal to 3, and n is equal to 8. So now I have 2 to the power of 3 times 8 plus 2 to the power of 3 times 8 plus 2 to the power of 3 times 8 plus 2 to the power of 3 times 8. Now 3 times 8, this is the same thing as 24. So now I have 2 to the power of 24 plus 2 to the power of 24 plus 2 to the power of 24 plus 2 to the power of 24. Now from this, I'll factor out 2 to the power of 24. So now I have 2 to the power of 24 times 2 to the power of 24 divided by 2 to the power of 24 is 1. So I have 1 plus 1 plus 1 plus 1. And if I simplify this in the parentheses, I get 2 to the power of 24 times 4. 4 is the same thing as 2 squared. So now I have 2 to the power of 24 times 2 squared. And now if I have something in the form a to the power of m to the power of n, this is equal, if I have something in the form a to the power of m times a to the power of n, this is the same thing as a to the power of m plus n. So 2 to the power of 24 times 2 squared, this would be 2 to the power of 24 plus 2, which is equal to 2 to the power of 26. So this is why our right answer is D. Now it's time for our bonus problem. 3,111 squared plus 2,889 squared. Now the first thing I'm going to do is I'm going to rewrite this as 3,000 plus 111 squared plus 3,000 minus 111 squared. Now I'm going to set A equal to 3,000, and I'm going to set B equal to 111. So now, if I substitute these in, I get A plus B squared plus A minus B squared. Now A plus B squared, this is equal to A squared plus 2AB plus B squared. And A minus B squared, this is equal to A squared minus 2AB plus B squared. So now, if I add these two together, I get A squared plus 2AB plus B squared plus A squared minus 2AB plus B squared. So first off, these two will cancel out, and I'll be left with A squared plus B squared plus A squared plus B squared, which is equal to 2A squared plus 2B squared. Now if I factor out 2 from this, I get 2 times A squared plus B squared. Now remember how we set A equal to 3,000 and B equal to 111. So now if I substitute these values back into here, I get 2 times A squared, so 3,000 squared, plus B squared, so 111 squared. Now 3,000 squared, this is the same thing as 3,000 times 3,000, right? And you may think this is hard because it's a 4-digit number times a 4-digit number, but we can actually for now ignore the zeros and we can just do 3 times 3. So that would give us 9, right? And then we simply add all the zeros after. So we're going to add 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. So our answer here is going to be 9 million. So now I have 2 times 9 million plus 111 squared. Now for 111 squared, this is equal to 111 times 111. Now, if we try to do this, 1 times 1 is 1, 1, 1, 1, 1, 1, 1, 1, 1. So I have 1, 2, 3, 2, 1, which is our answer. Now, 9 million plus 12,321 is going to be 9 million, 2 times 9012321. And this is going to equal 18,024,642. So this is our answer. Alright, so in this video, I'm going to solve the equation 7 to the power of x plus 7 to the power of x plus 7 to the power of x is equal to 147. So to start, I'm going to factor out 7 to the power of x, so I get 7 to the power of x times 1 plus 1 plus 1 is equal to 147. So 7 to the power of x times 3 is equal to 147. Now from here, I'm going to divide both sides by 3. So 7 to the power of x is equal to 147 divided by 3 is going to equal 45. sorry, not 45, 49. So I get 7 to the power of x is equal to 49, and 49 is equal to 7 squared. So I have 7 to the power of x is equal to 7 to the power of 2, meaning x is equal to 2.